So guys, look, thank you for everyone that's come along and registered. So this is the third TekCurious we've done now as a webinar. And I guess, look, for those of you that haven't been along to one of our TekCurious events before, normally we like to do them in person, but obviously with the way the world is at the moment, the webinar is our only choice. But so we've been doing them for a year now, so we'll be a year old at the end of this year, and they were born out of the desire to be able to just give something back to the tech community that we work with. As much as we'd love to talk all about IT recruitment and how great we are, but we refrain from that. So it's just a case where we bring sort of 2 or 3 senior speakers along for them to share some interesting stories, some challenges they've been through, and their views and opinions on things, and then for you guys to have an opportunity for some Q&A with the speakers afterwards. So we've got two speakers lined up for you today. Jonathan Holloway, who'll be going first. So Jonathan's a fractional CTO, so I'll let Jonathan tell you a little bit more about himself. Some interesting stories and a really good interesting topic to talk about. I first read about it on a blog that he shared many months ago on LinkedIn, which made me chuckle. So I kind of said to me, at some point you've got to come along and partake in one of our TekCuriouses. So he finally gave up me pestering him and agreed to do it. And then obviously we've got James Hunt, who is one of the senior engineering managers from OVO. So Chad and I have both known James for a good few years through a couple of different roles he's done. So James has got a really interesting talk he's done a few times before on microservice architecture. But again, look, I'll let James introduce himself through that. So the format will be Jonathan will come on and talk. Alex then will do a handover between Jonathan and James. James will talk, and then Chad will do a Q&A session at the end with you guys for both James and John. You'll notice down the bottom there's the Q&A tab, so just click on there. You can add your questions to it as we're going through, and then Chad will get through them at the end. But look, without further ado, I'll be quiet because none of you want to hear me chat on, and I'll hand over to Jonathan and let him get on with things. But good luck.
Hello, thank you, Carl. Right, let me just, excuse me while I just sort the logistics of this out, share my screen, get the notes up. Can everybody see my screen? Okay, well, Carl, maybe you can kind of...
Yeah, we can see it, it's all good, thank you.
Presenter view, 2 secs. The difficulty with 2 monitors, okay. Right, can you see that okay?
Yeah, perfect.
Brilliant, okay. Well, thank you very much, everybody, for coming along and to listen to how do I make the developers go faster. So this, just to kind of a brief intro to me, I'm John Holloway. I'm a kind of a scale-up startup kind of like CTO, and I work with businesses on an interim kind of basis. So typically I do 1 interim gig at a time, which is normally 3 or 4 days a week. And then I do fractional roles, which effectively means I help businesses out with specific problems. So some of those have been kind of things like white labeling platforms or basically helping them with gap analysis and around teams and what they need where. So I've been through this kind of this CTO engineering manager role multiple times over the last, 15 or so years. And that includes corporates with kind of like thousands of people, as well as startups, kind of 10, 20 in size. I guess the median team size for me is probably about 25. And this really was a kind of talk about a kind of productivity in development teams and how there are various misconceptions around, kind of engineers and basically kind of, I guess, output rather than kind of outcome oriented kind of views. So most of my work has been in kind of prop tech, healthcare, kind of e-commerce, travel, bits of fintech as well, and then the technology side of things has typically been with teams working with JavaScript, Python, Java, PHP. The predominant kind of things within kind of startup scale-ups I see are typically kind of Python and JavaScript being used. So what that means in terms of kind of teams is I'm looking at basically transitioning between kind of funding stages, whether that's seed, Series A, Series B, and then typically what good looks like. And this is one of the common problems that comes up. So really, and just one kind of point here is that there is fundamentally a mindset change between startup, scale up and corporate. And I think that's important to bear in mind when it comes to kind of teams and the way they think. So I think, pioneers and startups think very, very differently about building products compared to scale ups who are looking to kind of optimize and kind of grow that product out in corporates with established kind of products. But really, where this talk came from was I get, it's a common question I get asked by kind of founders and CEOs, and really, it's not just startups, it's basically organizations where there are symptoms where teams are not delivering necessarily what they said they would, and that typically is at the sprint or project level. And really, the kind of what we mean by the question is people want their engineering teams to go faster, fine. Business is competitive, and it's even more of a concern when you're trying to establish your product and find product market fit, and sell to your first, second plus customers. And the way you organize and build for that, I think, is slightly different, and iterating on that. So I also want to talk about this kind of myth of, a little bit, I'll touch on it, the kind of individual software productivity with engineers, and this kind of 10x mindset. And I've worked with lots of engineers over the years, and ex-Google, ex-Amazon, ex-Facebook engineers, and I think I've seen the pros and the cons associated with having those people, but more importantly about not having a balanced team and the right kind of a kind of balance of people within those teams and the kind of problems that it can bring in terms of productivity. So there are various kind of like challenges, I think, with this. So I've got 3 kind of main areas around productivity. And firstly, I think it's good to talk very, very briefly about the process of software development and what's involved in each stage, and then understand the good, the bad, the downright ugly in terms of the hacks or kind of optimizations you could put in. So we'll look at some of the ideas we've got and maybe the pros and cons of them. So yeah, and the last bit I want to talk about, which I didn't get to in the article, and is something that I very much want to get to with the next one and the next talk, and something that we're very kind of focused on at the moment, which is what do we measure, when do we measure it, and how do we do that in a kind of automated fashion. So I'll talk about some tools around that, and what we're focusing on at the moment. So software development process, I mean, everybody should be kind of familiar with something resembling this at their organization, but at some form you're looking to specify user behavior, design something which is fundamentally there to solve a problem, and then really look between product and engineering, the what and the how, to construct something which solves that problem. The implementation of that, I mean, it pretty much boils down to kind of code tests and kind of infrastructure code these days, and then some sort of review process with the engineers, potentially kind of the test engineers as well, and then some sort of acceptance process, and finally the release process. So let's look at how we can actually speed things up here and some ideas around it. So some people just start coding. The idea of a spec and being a startup is that you don't need to do design, and big upfront design and versus kind of the agile approach. Agile means just get on with it and learn from it. And I think there's a whole raft of problems associated with not thinking about what you're going to build initially. And it doesn't mean going to the ends of the earth and constructing a huge kind of UML based kind of like view of the world and breaking that down. It means just getting in front of a whiteboard and really trying to understand what you want to build. And the same can be applied to kind of kind of lo-fi and hi-fi fidelity prototypes. Is that you produce a lo-fi kind of prototype, learn from it, get some feedback on it before you actually rather moving from putty to concrete, so to speak, in terms of productionization of that. So in terms of UX UI design and technical design, I think it's important that that process isn't skipped, because fundamentally at that stage you're looking at this kind of measure twice, cut once approach to development. And it's also kind of an opportunity to actually look at, can you reuse something here, or is there something off the shelf that you can integrate instead of building it? If you skip that and go straight to the coding phase, my experience of engineering is that you build everything and you always think in code, and that is costly to kind of build, change, and get feedback on. So make sure that you do it right by thinking about some of these things up front. So it's also a good point to ask the developers, well, do you actually need to build it? And two of the kind of a couple of the hacks in the article I mentioned were revolved around the kind of mechanical Turk type approach that Amazon employs, whereby you don't actually build the process or the machine learning algorithm on the back end, and instead you do it via spreadsheets and a manual process. Somebody actually doing that kind of that kind of task. And that's great, because you've skipped the kind of build process of that, and you're able to kind of move towards a solution and iterate on that faster and get feedback more easily. So yeah, the less code the better, but I think skipping the spec or design process is a major problem. But being lean around that and thinking about the bare minimum you need there, that you can get away with without kind of finding problems further down the chain, is important. So another thing I've seen is that people just skip unit integration testing and almost the kind of code review and just chuck things straight into production. And I mean, that's great, but if your customers are finding the problem in production, that's not good. And if you have to do rework, it's more costly to fix it later. And I think there is a kind of a balance to be struck between what you write in terms of development code, what the minimum amount of kind of tests you write within the right area. So i.e. not automating the whole platform in terms of acceptance tests, which are very costly to maintain. There's a balance here by which you can do it. So skipping these parts is generally a kind of like a bad thing to do. Another kind of common thing is, let's chuck more people at it. And I mean, the common thing referenced here is the mythical man month, but it's not necessarily an anti-pattern. I mean, if you've got 3 engineers and you move into 5 engineers, then fine. You eventually you will get to a point where you're actually able to kind of do more development and get through things. But the ramp up time here is incredibly important, and seniority is important, particularly if you're upskilling kind of engineers. Having all seniors within the team is problematic. I mean, finding them is kind of hard, and the pool is much smaller. But fundamentally, if you take into account that ramp up time, then yes, you can throw more people at it, to a point which is what I mentioned here. Your team size on average, and or at least the max kind of like size, should be around 5 to 7. And the reason why that is because kind of bigger teams in terms of coordination effort, line management is much harder. I mean, I personally find that I can manage a maximum of kind of like 5 people generally, up to 7. And then in terms of, getting productive work done as well, it becomes very difficult when you get to 5 people. But there's also the ratio of product management to engineering to QA, and all the bottlenecks you've got in the process there. So a good example of this, if everyone has read the kind of Phoenix project, is the character of Brent, who I think is the busiest person in the kind of organization. All the work flows into him, and it's very apparent that certain work gets dropped because he's massively overloaded. And that kind of mindset there is the shift between individual contributor and kind of the coach mentality. And by doing that, you improve your kind of productivity by upskilling your people, by using kind of the people that already know how to do more than they probably should. More teams, I mean, yeah, okay. So we get to our kind of 5, 7 kind of people, and we say, okay, let's fire up another team within the organization. Or we can, I mean, the driver might be, let's fire up another team kind of near shore or offshore to do that. And as everybody's kind of seen with the COVID situation, I think for teams who are, they haven't done that before, I think, it's problematic. It's a learning curve in itself. And obviously there are kind of very kind of clear impacts there in terms of collaboration between those teams, and setting up things in such a way that you coordinate things between teams around kind of the bigger picture in terms of maybe the software architecture or the design, or even just general kind of collaboration on kind of certain areas. The other impact here is obviously that your code base, the way it's architected for different teams working across that, there's the chance for kind of conflict. And I think the next talk after this talks about microservices, and having autonomous teams focused around a given service, I think is a good place to be. But I think there's trade-offs there in terms of the way you kind of do it. But it is a hack. It can work. It can increase your kind of productivity in that sense. So, and I mentioned the article. There's 4 different areas where I talk about ideation for kind of making things go faster, so to speak, not necessarily the engineers, but 3 of those areas, product engineering and kind of more I've combined the kind of individual and exec into the people area. But I mean, in terms of the product area, looking at this off the shelf versus built here philosophy, and going manual before you automate is, a good example of how you can make things go faster in that regard. And in terms of engineering, the common problems I see here that cause at least the perception of kind of non-productive, well, productivity problems are when engineers and teams take on way too much work. And as a result of that, what they deliver within a sprint it can be kind of either they don't deliver all of it, or they don't take into account the other work that can come in, which is fundamentally unplanned. And if you don't have that a good model for handling kind of unplanned work, then that obliterates the planned work you've got within the sprint. So it doesn't really kind of like look like you're doing much. However, there's, coming up with a capacity model there, which is teams will kind of like code for maybe say 3.5 days a week, and that's the productive time they've got in terms of coding. I think that's a good thing to be able to kind of then take the work and plug it into that model to see what's achievable and what's not. The individual and the kind of the executive side of things, I think this, I mentioned this, but it's more about kind of having a duty of care and responsibility for your employees and making sure that you've not just got a good culture, but you're reducing kind of anxiety in the workplace, making people aren't actually burning themselves out and they are kind of working at a sustainable pace. And one of the tools I talk about in the end of this kind of presentation, and we've looked at it with teams recently, is we're able to see within the sprint when people start work, when they get to the kind of almost the pinnacle of the kind of sprint, and when we've burned them out, and when that kind of like drops to a kind of a low. And the point of using these tools that you're then able to kind of optimize that and make sure that your teams aren't taking on too much work. But I guess the important thing from an individual perspective and as an engineer, it's really about me working at a sustainable pace, making sure that I'm getting through kind of like my work in a reasonable way, but also that sleep, exercise, taking a break, and not pulling. If I pull more than 3 nights in a row, I think the 4th and the 5th day I'm pretty much toast in terms of productivity. But anyway, I kept away from the engineering level metrics in this, and that was very much the kind of focus of the next article. Something, and in some respects, this talk, but also the kind of some of the work, the research work we're doing in the tooling. So, in terms of measurement, I think change management is incredibly important within your teams and within your process. If you're changing something like sprint length, or you're moving from kind of sprint-based model to a Kanban model, or you're basically changing the way you do reviews or design, then it's important to measure whether you're actually going in the right direction. And I think the retrospective is a great way to look at some of these things. And more often than not, I see people sticking with things rather than kind of saying, hey, hang on a sec, this didn't work. Let's reverse it, can it, and talk about it. A different approach. So it's important to measure the success and failure of change you're making. And some of these things are hypotheses after all, and what works, for one company. So a good example being the Spotify model, and we've seen lots of people cargo cult that and apply it. And, I think there's problems associated with the model. And the way I've always thought about these is that you cherry pick the best parts from it. And one of the great things from the Spotify model was that kind of cross-functional kind of approach where you talked about things, specific things with people from different teams. So whether that was an architecture guild or something else, I thought would be great. Anyway, this is an area fraught with different kind of challenges, I think. And, there's lots to measure. We can look at engineer level metrics, individual contributor metrics. I mean, lines of code is the classic one here, because everybody's kind of, I think most people recognize it's a problem to measure things, one at an individual level, and secondly, to measure something like lines of code, primarily because what is produced by one engineer is it's not a measure by which you can apply to all engineers across the team, because the kind of changes that are introduced, some changes can be 10 lines in kind of like length, but have a massive impact in terms of the change to a code base or the change commercially to an application. But on that front, I mean, I do have a kind of method to differentiate engineers in terms of whether they're kind of, at the kind of senior lead principal, but it doesn't relate to how much kind of code they write. It's very much, it's an appendices in this, but it's focused more around things like how big is the problem that they're able to kind of like solve in terms of ambiguity, how well they communicate, how well they coach other engineers, their commercial impact in terms of the business. And it's less about, I think the more senior you get in those regards up to staff and principal engineer, it's more about the impact you have and less about the kind of the amount of code you write. So there's other kind of metrics, team level metrics, process and focus metrics, product metrics, which I won't get into here. That's a very different subject. And then operational metrics in terms of platform. And on the team metrics, I just wanted to kind of touch the whole kind of Brent story earlier on. The busiest person isn't necessarily the kind of, you know, the person who you should look up to as somebody to kind of exemplify with the rest of your team. That's the person you should be looking to turn into a coach. And also the kind of concept of presenteeism. The person who stays longest in the office, that's not necessarily the best judge. And, you know, bearing in mind that these teams have mixed kind of like skill sets, roles, and, you know, individuals contribute at all different levels. Anyway, I read Accelerate a few kind of months ago, and it was a bit of an eye-opener in kind of the sense that it talks about DORA, which is the kind of, you know, the DevOps research and assessment. And what they did was they did a survey over a period of 6 years, and they rated teams from elite to low performing. And there's some tooling around this that people have built, but these kind of metrics, I think, are really interesting to kind of like to look at for your team. And once again, be kind of wary of the cargo culting of such a kind of process. But the 4 key metrics that it talks about are these. So lead time, which is ticket created to production, the time it takes for you to get there. Success versus failed deployment. So if I stick a bunch of code into production and something fails and I have to roll it back, in my eyes, that's a failure. Or there's a kind of P1 critical bug, you know, so measuring that. The third one is the frequency of deploys. And the fourth one is called MTTR, or mean time to recovery, which basically means if you find an issue in production, how quickly can you actually fix that? So what they found with this, with these metrics, is that the elite performers had a shorter lead time. They could deliver things faster. In terms of deployments, things were more successful. They suffered from less kind of failed deployments. They typically did more deployments, so they would deploy every day or multiple times a day. And when an MTTR was typically kind of much lower. Those metrics. Sorry, just coming back to this. I think they're really interesting to kind of look at your teams and look at how they're doing, because one, the quantitative, you can actually look at and you can automate around your kind of process for this. So you can measure your lead time in Jira in terms of successful versus failed deployments. I mean, at the moment, I'm keeping a spreadsheet of these, but I think, you know, in terms of automating your tooling, whether that's Jenkins or Circle CI, it's very much the case that you should be able to kind of have a very simple dashboard with those kind of metrics updated on when things are successful in terms of deployment or failed. And then you can measure the frequency of those deployments. And in terms of time to recovery, well, yeah, I think, you know, when you find a kind of issue in production, measuring the amount of time it takes to resolve that, and whether you're going through a postmortem process, I typically stick it in the postmortem document for the things that went wrong. The second bit of measurement I wanted to look at was optimization, and this was very, very much around the development process itself. And I think there's very much kind of key, deeper level metrics that you can look at within your software engineering process in order to improve throughput, but also to eliminate the bottlenecks that you might have. And these typically lie around this kind of code unit integration, kind of like test level, the code review level, and some of the kind of acceptance testing that comes off the back of that. So review time was the one that I was like very much kind of interested in looking at. And this was looking at, typically in GitHub, you have a pull request, which is organized around a unit of work that is reviewed by another engineer and approved before it's released. And I wanted to look at all the open kind of reviews that were there, who was actually kind of assigned to actually review those, and to look at the amount of time that a review request was open for. And the whole point of this was to optimize throughput and eliminate that bottleneck whereby a pull request was open for a long period of time. So I've got a little tool on GitHub if anybody's kind of interested in contributing to it. It's a big lump of kind of Node.js, uses something called OctaKit and the GitHub API. But fundamentally, it looks at the GitHub API part, basically pulls all the kind of pull requests out and then measures how long those pull requests have been open for. So like down the right there, we've got a list of our tickets. So it does this for the current code base, and the current set of pull requests that are open. And typically what we're looking for is that a review is not open for any more than kind of a day or 24 hours. But I also wanted to kind of look at what the average was on a daily basis, and to look at whether the team was actually getting better or kind of worse within this area when it came to kind of reviewing these requests and merging them. So effectively, we were able to measure, based on that threshold of 1 day, how many requests we had that exceeded that, and the rest that came in. So I think, given this particular day, the average time to actually handle these reviews and merges was about kind of 6 hours, which is pretty good. And that was 100% of the merge request. That isn't always the case. I wouldn't, I'm not saying that, it's a team that kind of always hits that kind of 6 hour mark. I mean, it does fluctuate, but what we've done there is to pick a metric and said, what is a reasonable amount of kind of time for this to be kind of resolved within, and then put some tooling in place to make sure that we're able to measure that and see whether the team is getting better or worse. So off the back of that, I started with this, and obviously, I think I broke the product rule of, I built it before looking whether there was something out there that I could integrate or at least reuse. But after I had a talk with Haystack, which I haven't included the link here, but it's use haystack.io, and that provides somewhat deeper level view of these metrics in addition to the pull request length that I've just talked about. And using Haystack, we did the onboarding process, we did the analysis of our kind of repository or repositories, so front end, back end. We work off a microservices architecture as well, but in kind of like, it's like fully JavaScript environment. But that was able to tell us a whole bunch of stuff about our team that was super interesting. But I was less interested in throughput and more interested in whether we were actually burning the team out. And the way that it measures throughput is to look at pull requests and the number of pull requests kind of generated and merged within the context of the sprint. And then also when people and the teams actually worked. So we could see whether people were working overtime or weekends, and whether they were burning out from a result of overwork. And then finally, it looks at kind of rework time. So if people were pushing crap tickets out, then we were able to kind of pick up on that and look at the time whereby that ticket moved from, it was tested, there was a problem, it moved back into kind of development. That was typically the whole point of that. So I think there's a whole bunch of tooling around this, and there's a whole bunch of interesting metrics to look at. And Haystack was the one we chose, and we're in the process whereby we've seen the last 6 months of activity with the team, and we've looked at the data within that to try and improve the way we deliver. So that's pretty much it. 25 minutes bang on, pretty much. But what I'd encourage people to do is to have a look at the DORA kind of metrics, do the DevOps quick check, and look at some of the metrics you've got around your kind of team at the moment, and to look at some of these kind of like metrics in kind of like greater detail. Obviously, take into account that much like I said with the kind of the Spotify model and cargo culting, that it's not a kind of the be all and end all, but it's a set of metrics that I think are really useful for kind of understanding where your team are and how in terms of delivery at the moment. That's it. Thank you very much. Of course, the obligatory kind of hiring slide. If you are going through this kind of an understanding of baselining your organization, planning and improving, then you can hire me. I've also used some of the tools.
We can solve all of your problems. It's not a problem.
Silver bullet. What I'd say is no team is like another, and no organization is like another. Everybody's got their unique kind of like challenges, and I think they're all solved in very different ways. So, but thank you very much.
Great, thanks, John. Really interesting talk there on tooling and metrics around how to make your team go faster. Tim, we've got your question in the Q&A box there as well. Just a reminder that we're going to do the Q&A at the end of both talks. So wanting to introduce James, who's the engineering manager at OVO, going to do a talk on microservices and why they are great and why they sometimes aren't so great. So without further ado, we'll pass on over to James now.
Thank you very much. Can you see and hear me okay?
Yeah, perfect. We've got everything.
Brilliant. Great. So, yep, my name's James. Again, sort of obligatory sort of push for OVO, which I'm engineering manager at. It's a company that's obviously the second largest energy provider in the UK now, and very much sort of takes tech very, very seriously. So I'm going to talk very briefly about kind of microservice architecture and just kind of introduce a little bit about kind of why you would want to use that, when it would be appropriate, and probably importantly as well, when it wouldn't be appropriate. So first of all, I think it's good to sort of get an overview of what a service is. So we're talking about microservices and their opposite with monolith services. So what it actually is a service. So a service is something, you know, it's typically a program which will run on a server somewhere, and it will perform some sort of background function. So that background function might be responding to client requests. It might be updating a database. It might be sort of pulling information. It might be sort of interacting and doing some sort of process. So in comparison, a monolith service is essentially the way that software used to be developed, as in a team would typically have a service that they would contribute to. So it would be, instead of thinking about a service delivering on a need of an organization, it would be much more delivering on a need of a particular team. So a team might have 2 or 3 different functions, and they would all end up in the same service. So over time, as kind of that team grows, that team takes on new features. Those features are added into kind of that same existing service. Likewise, there'll be kind of one data store if needed, and that data store will again grow to encompass perhaps everything within the company. So there's a lot of things good with that. For one thing, it's very, very simple to develop in that way. So it's very simple to kind of actually code. You haven't got to worry about dependencies. You've only got one code base. It's very simple to deploy. You only have one thing that needs to be released. You don't have multiple dependencies around all of that. It's very simple to test because you can test everything as a black box. And it's very simple to get started. You can create a monolith service in 15 minutes, deploy it somewhere, and that's your whole system up and ready to go. But there's some things which are bad. It doesn't solve all problems. So as your team grows, the complexity of what you're delivering grows. The dependencies, that all of the various sort of different features that you're building, they grow, and there might be sort of clashes with dependencies, which cause you to sort of upgrade different things and different sort of incompatibilities just within the single system. Scaling this is hard. Say you have an authentication which needs to handle 1,000 requests per second, but then you also have a very heavy memory intensive business function which only gets called once a week. You need to scale both of those 2 very different use cases at the same time. And it can be hard to kind of move and introduce sort of new changes into the system because there are so many interdependent parts that one change in one place might impact several changes elsewhere. And when you deploy it, it's simple to deploy, but you've got to deploy everything at once, which causes a lot more risk on the system. Say, for instance, you've got a small change that needs to happen in that system that only needs to run once a week, that you need to deploy your entire system and potentially introduce bugs across that. So what can we sort of do about kind of improving on that monolith? So instead of actually, you know, the old way of building a service for a team or around a product, we can actually sort of break that down and build a set of services actually designed around a business function. So for instance, we can pull out authentication and make that into its own separate service. We can pull out users and say that's going to be a separate service. search, etc., and keep going until we sort of deconstruct and break down that monolith into a number of different individual services, each around a single business function. So, and that's essentially what microservices plan to do. There's it's an architectural framework, or a number of architectural frameworks, for how you can deconstruct a monolith service into a number of individual self-contained services, which can then all communicate to each other and present from perhaps a single API in exactly the same way that a traditional monolith architecture will be. So some of the characteristics that you will see with sort of microservices, as I've said, it will generally be organized around business capabilities. So for instance, if you have an e-commerce store, you might have customers, so you would have a customer service. You might have inventory, so you have an inventory service, orders in a separate order service, etc. It's language agnostic, so you can choose for each part of your system the most appropriate language that delivers for that. So for instance, if you had a data science capability, you could write that in Python, but then for something else which might need sort of more enterprise level stability, you could write that in an enterprise language like Java or .NET. There's obviously lots of communication between the different services. So that communication is generally via REST or another communication like gRPC, or quite commonly sort of async through message buses. That data store is generally then broken down, so each service is responsible for its own data. So instead of having one monolithic data store, each service then has its own individual data store, and that data is replicated across services as needed. It typically has a gateway. So instead of just one service, there are actually sort of multiple services, and they appear as a single API using a gateway, which will then route through to the appropriate service for everything that's needed. Service discovery. So for instance, when you have kind of 1 or 2 or even sort of 10 monolith services, it's easy to kind of hard code in IP addresses for those static services and those static servers that are going to be hosting those. When potentially you've got sort of 10, 20, 100, 1,000 microservices, you need a way to quickly be able to identify those microservices, be able to re-upload and sort of discover those without hard coding and relying on IP addresses. So typically there's some form of service discovery. And microservices will be developed as small container deployments. So instead of thinking that one service or a set of services will be deployed on perhaps a Tomcat server somewhere on a virtual machine, instead microservices will be deployed almost always in some sort of container deployment. So having done all that, what benefits do you get? So for one, complexity becomes isolated. So as I said, we can then start working on business logic and introducing new things there without worrying about kind of authentication or users, which is going to be very fixed and not changing. Makes it scaling very easy. We can scale an authentication service, which can handle thousands of requests per second without worrying about scaling sort of memory hungry and other sort of services. It's very easy to kind of add new technologies. So for instance, if we wanted to add a headless browser based on sort of Express and Node.js, we can very easily sort of drop that into a enterprise system. We don't need to worry about the thing that we really want to use not being compatible with our language. And it's easy to then sort of replace that as long as it keeps to the same contract with just new deployments in different languages. It's a lot easier for new developers to pick up because they only need to work on small little areas instead of a kind of a huge monolith that they're trying to sort of understand everything in one go. And failover is easy to manage because it's not a case that your entire system will either be up or down. It'll be a case that there'll be certain things which just won't be able to function. So authentication, business logic in this case might work, but you're just unable to fulfill search. But there are a number of drawbacks as well. So for instance, carrying on from the failover, there is a lot more work that's required to sort of implement sort of failover and have your system understand that actually a number of services might not be available. Business intelligence can be trickier because you've got multiple data sources that you need to pull information from, and they need to sort of bring everything through into a single sort of dashboard, although a lot of tools can handle that now and been improved. Large-scale changes can be harder to manage. So while it's really easy to add in new services, it can be much harder to kind of say re-architect your system. So if you needed to change an existing service and split that into two, there's an awful lot of other services that are all currently running and deployed that all need to be changed at the same time. And it's much harder to actually get started with this as well. So initial deployment and DevOps, instead of kind of very quickly being able to put a service on a machine and have that running and exposed to the world, there's a lot of infrastructure and DevOps required to kind of get your whole suite of microservices and the gateway and service discovery and everything else running. So it seems like a lot of work. So why would you do it? So first of all, it is a lot of work, you know, and it's clearly not right for all projects or products. And it can be very hard to transition between the different architectures. As we've seen, it's very difficult to suddenly sort of split up services. So really, it's proper planning prevents poor performance. As was talked about in the last talk, really the design aspect is so important, and understanding what your product or project is going to be used for, so that you can define and declare the right architecture. So here's a little cheat sheet for when kind of it's useful and when it's not useful to use and consider microservices. So for instance, if you've got a small project or a time limited project, then it makes perfect sense for just a monolith to be used for that. If it's got a single function, if you're not going to be sort of crossing over into multiple functions, you're happy with a single technology, and you just want to deploy something on one server, then a monolith is definitely the way to go. It's going to be much easier to do for you. But if you've got sort of large, non-time limited products that are just going to keep growing and growing and growing with features, you've got many functions, you want to be deploying kind of in an automated way in cloud infrastructure, then microservices have got to be kind of one of the things that you think about the ways of going. But the good news is that there's a lot of help out there. So some of the things that you would be sort of looking for and has really sort of taken off because of microservices are things like infrastructure as code. So when you think that you've got a huge DevOps thing to get going, infrastructure as code enables you to very easily sort of spin up and change that DevOps and automate that process. Orchestration layers like Kubernetes enables you to deploy lots of microservices and have their lifecycle managed for you, so that instead of going onto a server and restarting your monolith, it's very easy to have all of that put to an orchestration layer whereby services will automatically be spun up on demand as load increases, etc. Service meshes. So service meshes take away a lot of the complexity around communicating between microservices. So they enable sort of securely routing messaging, they enable circuit breaking, they enable several different things around kind of the service discovery and everything like that. So service meshes are another incredible tool around kind of for microservices. There's advanced proxying for the gateway layer. So for instance, technologies like Kong are really powerful and give you quite a lot of functionality actually at that front layer. And then there's various sort of frameworks which are specifically set up for interaction between sort of microservices. So at this point, it's worth actually sort of bringing up that there is a third option. And that third option is serverless. So serverless is basically third-party, out-of-the-box services that don't require you to develop or deploy anything. So for instance, your authentication service could be provided by something like Auth0. Your data storage could be something like Google Firebase, and various sort of frameworks around those. And also, you could just take your code and deploy that as a function which is run on demand using, say, Google Cloud Functions or AWS Lambdas. So therefore, you don't need to worry about deploying something as a server at all. So I think serverless should be always the first option to kind of look at what is already out there, what is available for any sort of individual capability, and some of your services, or maybe your entire sort of backend system, could be replaced by serverless options. So there's a couple of things here just around kind of sort of getting started. So definitely sort of read up on kind of microservices architectures. Domain-driven design is very, very useful in kind of coming up with sort of the architecture that you would use. Deployment options, everybody who's thinking about doing this should be really familiar with sort of Docker, Kubernetes, Istio, etc. And then there's various sort of, every language has lots of different frameworks which can take advantage and are set up to enable microservices. And that's me. Thank you.
Thanks very much, James. Thanks to both of you, actually. Now would be the opportunity to ask any questions to the guys. We've got 4 already in, so we'll crack on. I'm going to put this in the order of the people that they're directed to. If you want to direct it to someone specific between the two of them, then just maybe put the name at the front. But, guys, chip in if you want to answer the, feel free to get involved. So Tim Gaines has asked the question, what impact, if any, does architecture shape have on development cadence? That would be to Jonathan, but feel free, James, if you've got an opinion as well.
Sure, yeah. It's a really interesting one, and it's something I didn't cover in the original. It has a huge impact. I think, when we talk about the differences between microservices and kind of, monorepos, or even kind of the architectural structure of a code base, if you're dealing with a messy code base, it's going to have a massive impact on your program, your engineers. We read code way more than we write it, and the initial kind of hump is is in understanding what's actually there in order to change it. So I think it's keeping a check on at least tech debt, and also the bus factor in terms of who knows what in the code base, and upskilling based off that. That is a kind of I think a good way to kind of have a better understanding of the code base. And obviously, I think that whole kind of rewrite refactor, it can be much more efficient to rewrite something than refactor your way out of it. So I think, in terms of productivity, architecture is kind of critical.
Okay, excellent, thank you. Another question from Tim. Any success with swarming, mobbing, or other collaboration techniques?
I think one of the most underrated things, it really is taking you consider your bus factor in a code base. There's kind of let's say that you've got 40 services. Somebody doesn't, none of the team know 5 of the services. Actually providing a review point around that within off the back of a sprint, which is you all get together within the room, you look at the code, you try and understand what it is. Maybe one person understands it way better than anybody else, and they do the kind of the talk through the code. I think that's massively underrated. And what I found with pairing, swarming, mobbing, with pairing, senior engineers tend to hate it, and I think it's really beneficial in terms of onboarding to understand the code base through pairing with somebody else. But more often than not, I think people are reluctant to do it. But I try to encourage it, but the uptake on it can be problematic depending on how senior the organization is.
Okay, excellent. And from Jason, have you ever trialed any of the toolings such as Git Prime or Static Object? If so, what are your thoughts?
Sure. So when I mentioned Haystack on the call, that's usehaystack.io. It's a similar thing, whereby they provide an analysis of your code base, and they try to provide these metrics around productivity and what they mean, whether that's pull requests and throughput, or kind of rework time and things like that. I think they're really useful to inform. I think they could be used they can be quite dangerous in the sense that, which comes on to your the second question about anti-measurement. I think they can be quite dangerous things, but I treat them as lagging metrics rather than leading metrics, and I very much look at them in order to So burnout was the kind of one thing I was kind of concerned with the team, and that's what we used the tool for.
Yeah, and I think you touched on it a little bit. Have you found technical teams anti-measurements because of history around a lot of function points, etc., such as getting them to engage with measurements is difficult? If you've got any other tips as well.
No, I think it can have a pretty drastic impact on your team, and I think in terms of confidence and trust, it has a. If you mention that you're measuring people by the number of lines of code they write, then it's not the right thing to build within an organization. Having a team own an idea and the commercial impact of that idea, that's the right way to go with that. So if they can roll something out into production that massively increases conversion or generates a whole pile of revenue for the business, that's the right place to be, and that's the right thing to measure as a leading metric.
Okay, thank you for that, Jonathan. This one's aimed for James. I've heard that microservices architecture moves the workload from compute to the network. Any views from Trevor?
I mean, it can do. I mean, the network can be a bottleneck depending on kind of how it's designed. And one thing I didn't talk about is kind of, when do you go away from a microservice architecture and when do you kind of balance the two? And I think it's the same with anything. You need to learn a lot about the framework and know why it's useful and then why not to implement it. So certainly if you go down a pure microservices route and every single business function is deployed as a separate service, which I know some teams have done, then there is an awful lot more network overhead. But actually, if you start combining kind of logical services together into kind of like mini monoliths, if you like, then actually you kind of limit that an awful lot, and the benefits that you get on the other side are still there. So yeah, I can see that argument. I think it depends on how it's implemented and how it's architected.
Okay, thank you very much, James. Do we have any other questions for our panelists?
I've got one. If that's
Carl's got one. He's bound to have one.
I was very disappointed. I was thinking I need to get a new system. It doesn't allow me to ask questions. It'd be interesting to get both of your views on it, and clearly, look, it's probably tainted towards recruitment because that's all I know. But I guess, look, one of the things I was really intrigued to get both your opinions on is obviously the more and more people we're speaking to, especially people in similar roles to you, obviously since their development teams have been working more and more remotely, of sort of going, well, actually, our productivity levels have either stayed at least the same or if not increased. So one of the common things we're seeing is a lot of clients going, well, look, we're not really intending on bringing sort of engineering teams back into the office at any point. But I guess I'd just be keen to know what your thoughts are on that, whether that's a positive, negative, and how you're going to go about sort of transitioning into that. But then I guess purely from a recruitment perspective, I guess we all know how challenging it is to find really good engineers. And I guess, are you going to feel comfortable? Are you going to open it up to right across the UK? Would you look at anyone at any end or any point in the UK? Or are you still going to think you're still going to need that team so people can still come into like a collaboration hub every few weeks? I was really intrigued to get your opinions from two different scales, from sort of an OVO and then from John, from what you're seeing in some of the real leading edge startups you're going for. And I'll go to you first, John, because you're not on mute, so it just makes it nice and easy. So we'll go there. We'll come back to you, James.
Sure. Yeah. So I work on an interim basis at the moment. I've got nearly kind of 13 people in Belarus, and I've got another kind of 10 people in India, plus the kind of on-site team. I think in terms of productivity, personally, this whole kind of like remote only it's a challenge for me because I like to be in the office part-time and out of the office kind of part-time. So in terms of some of the kind of exec stuff, it's way easier to be in the office, but in terms of kind of coding and everything else, I find it much easier to be remote. I think Paul Graham came up with a kind of difference between the manager and the kind of, the engineer in terms of the way they work. And a manager works on an hour by hour kind of basis, and an engineer works on a half day basis, I think. And I think that whole split between office and kind of remote and in the house is a big problem. I think I mentioned as well, it's like just moving about in the house does massive kind of amounts for my productivity. But in terms of, sorry, what was the second part?
No, that's right. So it was kind of, if you do have a fully remote team, would you feel comfortable looking at talent across the length and breadth of the UK, or are you still going to want them to be within a close proximity-ish? Because I guess we hear more of people aren't referring to them as offices now, more collaboration hubs. So are you wanting them still to be near enough for that? And that was it.
Sure, yeah. I think we'll see a lot more of people building teams in some of the major cities in the UK, particularly not just because of the current crisis with Brexit coming up and a lot of the kind of costs associated with kind of outsourcing, which, it has been an increase in terms of, I mean, personally building a collaboration hub here in Bristol, that would make a lot of sense. But predominantly the way we're looking at it is the south of England and building the team out across here, not just London, which is, previously been the case for some companies. It's not London and the rest of the UK.
Some more questions coming in. I appreciate that. We want to get through and make sure that we get these questions answered. Is QA a separate function or responsibility of each developer? Do you still use dedicated manual QAs or focus on automation? Is having a dedicated QA team incentivizing developers not to automate and write tests? Thoughts?
Who's that to?
Go on, James.
I mean, I can
Go on,
answer that
James.
for myself. So in OVO, we don't have, well, where we have QA, I think it's for external services and, with hardware, like we deal with sort of physical gas meters, for instance. So we have kind of QA looking at that. And I think there's then the shift left side of QA about kind of making sure that they're more involved in writing acceptance tests and understanding kind of things as it comes into the development team. Then once it's in with the development team, essentially everything then is done via automation. So kind of we make sure that we deliver fully automated tests, and then that goes then straight to deployment. So there isn't a manual QA step, and I think that's kind of absolutely key, especially for Jonathan's point about getting to releasing multiple times a day. I think you need to have you just can't rely on a manual step in doing that.
Okay, and then Tim's just chipped in with a question: how do you organize your teams for microservices, vertical or is it horizontal?
I think actually it makes it a lot easier, and I think it depends on very much the team. I think then your team becomes a lot easier, as in, would you naturally have a vertical team or would you naturally have a horizontal team for delivering that? So for instance, kind of if you had data science as a function, then that would be something that you would imagine delivered as a horizontal team feeding into many, many different verticals. And they would have, say, a set of services supplying kind of those verticals around that. So I think it kind of gives you a lot more flexibility to choose the right, whether it's a vertical or horizontal, for that business capability that you've got.
Okay, excellent. And in the context of microservice event-based architecture, and sort of related to Trevor's question, I find that it pushes the complexity to inter-service interaction that can be difficult to reason about, that you don't have with a monolith and the use of tried and tested tools, IDEs. Do you have any useful tools you've come across that can help draw this out?
So, yeah, no, I completely agree, and that's the complexity essentially around microservices. The fact that you are decoupling these services, and that means that you are making that complexity into the kind of that inter-service communication. I think the tools that I would say is kind of looking at Docker for a local environment. So not only do we kind of have tools which deploy everything into sort of an orchestration layer, but having all of those that can be run locally, I think that's really key, so that your message queue, all of your services that you're not currently sort of developing on, can all be sort of launched using sort of Docker Compose, and then that will enable you to kind of sort of test and run everything locally. And that's really key. I think once you've got that set up and you've got all of your services running in containers sort of locally, then actually it becomes a lot easier. Hope that helps.
I think you're still on mute, Chad.
Yeah. Do you find that microservices lead to a duplication of data, and how do you manage that?
Yes, but then the question is, as long as the data is eventually consistent, is that necessarily a bad thing? So one of the mechanisms that you can use with microservices is the fact that you can say anytime data is updated, publish an event, and then any services which then might rely on that data further on can consume that event and be eventually consistent with the atomic sort of data structure. So from that point of view, as long as you've architected it in the correct way, then duplication of data doesn't really become an issue. So duplication of data is just something that you're doing to make your life easier.
Excellent. And following on from that, what do you say to senior management that still want to measure team performance by story points delivered?
I take it that one's for John.
Yeah.
Story points.
Jonathan. Yes.
Here's my problem with story points. So at some point, it's all well and good saying, okay, you're going to measure a story based on story points, but somebody in the business at some level decides to roll that out. And when they say, fine, this is kind of 5 story points, somebody will equate that back to time. So I just use time. And I think, when somebody asks for an estimate, you say days, weeks, months, that's the way you keep it. But in terms of what you say to them, I mean, I think measuring team performance by, well, firstly, I tell them story points are a silly thing to measure things by. But secondly, I get to the root of what they're actually looking for in terms of, but moving them to be, I think the kind of the most popular phrase at the moment is moving them to be kind of outcome focused and not output focused. That's the key thing. And, getting senior management to realize that the team are there to deliver an increase in conversion. They're there to in kind of increase revenue or an increase in development productivity. So yeah, I think understanding where they're coming from with there and asking the root of the, what is the root question they're looking to answer, because that to me seems like a symptom.
Fantastic. Thank you, Jonathan. Any other questions at all? No? Got nods from everyone as well. Look, thanks very much, James. Thanks very much, Jonathan. Do you want to step in, Carl, as well? I think it's been hopefully really... has any of the other panelists got...
Just at a critical moment, mate, I think your Wi-Fi has dropped out.
Got any other questions? The only question I had across... Oh, it's my Wi-Fi. Who's cutting out? You still there? Can you hear me?
I think we can hear you okay.
Oh,
I think, yeah.
Oh, it must be Carl's Wi-Fi cutting out again. Typical. Jonathan, burnout rates, controlling them on and offshore, and maybe talking, how do you actually manage the time and then the element around on and offshore and nearshore teams? Do they work differently? Can you get them in line with one another?
Get them in line with each other in terms of when they work or basically...
Yeah, well, in terms of the amount, the output, and looking at their burnout rates. I mean, is it very much? I mean, I know it's cultural differences and all that kind of good stuff, but
no, I think there are cultural challenges with it as well, and I think in some countries the idea of working a 12-hour day is just done. That's just the way it is. But getting those under control, I think it's clear to me. I've got in terms of a lead engineer who's involved in deployments, and you see it when past kind of like situations whereby it's very clear that the mistakes come from as a result of kind of from overwork and burnout. And I think using Haystack, we've been able to kind of look at that and say, well, why on earth are you working a Saturday and Sunday as well as the other 5 days and pulling 12 hours? This is not, because it's not just damaging to them and their health. It's actually, you look at it, and it's not healthy for the organization either. It doesn't encourage a kind of a sustainable kind of mechanism for development. And indeed, a lot of the DD exercises I get involved in, that's one of the kind of things you look at, is very much, can they deliver what they said they would? And in terms of turnover rate with the organization, are people just leaving because they're just burnt out? So, I mean, it's really important that people, kind of keep that in mind, I think.
Brilliant, thank you. That's answering the question. Look, it's 4:40, so we've just whipped over an hour. I do appreciate you all being on. It's been excellent meeting you. Any other follow-ups, any sort of information you guys wish to share, then get in contact with us, and I'm sure James and Jonathan will answer any follow-up questions. But fantastic. Thanks for being on. And guys, really appreciate you coming on as well and presenting to us. It's been very, very useful. So thank you for your time, everyone.
Thank you.